The fifth lesson of this section is on vertical and horizontal lines. And so far we've taken a look at oblique lines, which are lines that are slanted. But in this section, what we're going to do is just review horizontal and vertical lines. And again, you've seen these back in algebra, but we're just going to take a little bit of time to make sure that you're okay with them and review a little bit. So what we have here in this first exercise, it says in the graph below, a horizontal line is shown in part A and a vertical line is shown in part B. Answer each question below with the respective graph. So first thing, what is true about all the points on that line? Well, if we start looking at the points that are labeled, this point right here, if we look at its coordinate, that would be 1, 2, 3, 4, and then up 3. So that's the point 4, 3. And this point over here would be -2, 1, 2, 3. And if we pick other random points on that line, this one here would be 1, 3. This one here would be 2, 3. And so what I notice is that every single one of those points has a y value that is 3. So what is true about all the points on the line? All y values are 3. And then for letter B, we have a vertical line. And again, what is true about all points on this line? Well, if we start looking at the points, this point right here, its coordinate is 2, -1. And this point up here is 2, 4. And again, if we pick other points, we have 2, 0, we have 2, 1, we have 2, 2, 2, 3, and so on. So what is true about all the points on that line? All x values are 2. So then what they want us to do next is write an equation for both of those lines. Well, if all the y values on this line are 3, then the one thing that I know for sure about that line is that every single point is going to have a y value of 3. If we look at the graph also, this line only touches the y-axis. It never touches the x-axis, and it touches the y-axis at 3. So the equation of this line is y is equal to 3. X can be anything, it doesn't matter what x is, but the y value is always going to be 3. And then the same thing with our vertical line. If all the x values are 2, then every single point on this line is going to have an x value of 2. If we look at the graph, the line only hits the x-axis, it never hits the y-axis, and it hits the x-axis at 2. So the equation of this line is x is equal to 2. It doesn't matter what the y value is, the x value is always going to be 2. So now what they want us to do next is, using the 2 marked points, calculate the slope of the line. Be sure to simplify your answer. So we have 2 points here. Now, we can do this in one of 2 ways. We can graphically find the slope, or we can use our formula, and so let's walk through both ways. Slope is rise over run. So on this line, if I go from the point on the left to the point on the right, I'm going to rise 0. I'm not going up at all. And then I'm going to run 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. So I'm going up 0, and I'm going over 6. And 0 divided by anything is 0. And we can also do that using the coordinates. If we subtract our y values, we get 3 minus 3, and then on the bottom 4 minus -2 would be 4 plus 2. And we still get 0 over 6, which is 0. So the slope of this line is 0. Now this other line, the vertical line, if we do the same thing to go from one point to the other, this time I'm going to go up 1, 2, 3, 4, 5 units, and I'm going to go over 0. And when you divide by 0, the fraction is said to be undefined. Okay, and you can write it out as undefined, or you can write it with a 0 with a line through it. Both of those things mean undefined. And again, we can also do it using the points. So we would have 4 minus -1, which is 4 plus 1, and then 2 minus 2. So we get 5 over 0 again, which is undefined. Now, if you're not sure, for some reason this whole dividing by 0 or 0 divided by something tends to confuse people. So what I want to show you really quickly is, if you have your calculator, okay, if you have your calculator, you can actually use it to figure out what is happening here. So in the first example, we had to divide 0 by 6, and that gives you 0. And in the second example, we had 5 divided by 0, and that tells you that it's undefined. So if you're not sure if you're going to get 0 or if you're going to get undefined, use your calculator. It will help you understand, help you out with that. All right, so back to our picture. This line right here is going to have an undefined slope. And here's the way that I think about it. If this was like a path that I was trying to walk on, I'm not rising at all. I'm not going up at all. I'm just staying flat. So the slope of this line is 0. All right. If I were to try to walk on this line, it's pretty much impossible to climb up the side of the wall. So I can't walk along this line. I can't walk up the side of the wall. It's impossible. My slope is undefined. So hopefully that helps you kind of sort through those two. All right, down at the bottom of the page, in example number 2, it's important to have your facts about horizontal and vertical lines. They're easy, but people often make mistakes. So a horizontal line is parallel to the x-axis. All equations are going to have the form y is equal to some number and have slopes equal to 0. Vertical lines are going to be parallel to the y-axis. All the equations are going to be x is equal to some number, and they have slopes that are undefined. All right, so let's take a look at the back. All right, so on the back, what we have are 3 equations that they would like us to graph, and then we're going to shade in the figure that is enclosed by those lines, and we're going to label each line as we go. So with this one, we're going to start with a line whose equation is y equals negative 5/3 x plus 4. So with that line, we have a y-intercept of 4, and we have a slope of negative 5/3. So from here, I'm going to go down 5 and over positive 3, and I get a point, and I'm just going to do it again. And there's my line, so I just go ahead and connect those points. And it does tell us to label, so this is y equals negative 5/3 x plus 4. Now I have y equals 9, so that's the line that only hits the y-axis at 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And if it only hits the y-axis, it has to be a horizontal line. If it was a vertical line, it would hit the x-axis. And then we have x equals 6. So this is a line that only hits the x-axis at 6. So that's going to be our vertical line. And then it says to shade the figure that is enclosed by those 3 lines. So we get this triangle right here, and we'll just kind of shade it in. All right, the next example, exercise number 4. This one says, since we now have the basic horizontal and vertical lines, we can also use them in our transformations. So we're given triangle ABC is shown in the figure, and A prime, B prime, C prime is a reflection over the line y equals negative 2. So y equals negative 2 is going to hit the y-axis at negative 2. So that's going to be a horizontal line. And we can reflect over it, and then it wants us to state the coordinates of the image of all 3 vertices after the reflection. So this point C is 1, 2, 3, 4, 5 units away from that line y equals negative 2. So we're going to bring it 5 units on the other side, and we'll label it C prime. Point B is 1, 2, 3, 4, 5, 6 units away from that line, so we'll go 6 units on the other side, and that will be B prime. And then A is 3 units away from that line, so we'll go 3 units on the other side, and there's our A prime. So connect the dots. We get the triangle, should be the same shape, same size, just flipped because it's a reflection. And it does say state the coordinates, so A prime, B prime, and C prime. So go ahead and find those coordinates, jot them down, and make sure that you know where they are. And then the last example, number 5, it says in the graph shown below, M prime, N prime, P prime is the image of triangle MNP after a reflection of which of the following lines. So this triangle right here, MNP, is being reflected over something, and it results with the triangle M prime, N prime, P prime. So see if you can figure out which one of those lines that triangle is being reflected over.